Here are some videos generated by WAN. These videos were generated on an 8GB VRAM GPU with 32GB RAM, running on an i7 6th generation processor. It's slow, but it works. The model used here is Q6GGUF. Today, I'm going to show you a step-by-step WAN video workflow using native nodes only. Let's load the K-sampler node. This acts like the CPU of image generation in Comfy UI, processing latent noise into a final image by iterating through the diffusion steps. It plays a key role in refining the image based on the selected sampler. I like to think of it as the core processing unit, much like the processor on a motherboard or the CPU in a computer. It handles the essential computations, driving the entire process. But the K-sampler is the CPU or processor, meaning everything must pass through it to be processed. This concept makes it clear why the K-sampler is essential in the workflow. For YN videos, set the steps to 20. The CFG scale should be 4 for image to video generation. For the sampler, choose UniPC and set the scheduler to simple. These are the recommended settings for generating WAN videos. Next, let's add the positive prompt and negative prompt nodes. I like to set the positive prompt node to green and the negative prompt node to red for clarity. Now, we'll add the WAN image to video processing node. Like all other nodes, we'll connect it before the K-sampler. For resolution, I preferred in 24 by 576. This maintains a 16:9 aspect ratio. Some people use 960 or 8040, but that reduces quality, especially in hair details. A 1024 pixel width is ideal, since Flux images default to 1024 pixels. Next, we'll set the frame count of 49, creating a 3-second video. You can go higher, but this workflow focuses on 8 VRAM system. So this settings makes sure you get good quality and not crash with out of memory. Now, let's load the model node. Since we're using a GGUF model, we'll select the GGUF loader node and choose the Q4 model. I use the Q6 model, but since I've received comments that Q6 crashes on 8GB VRAM GPUs with less than 32GB RAM, I'll use Q4 instead. This ensures that everyone can run it smoothly without crashes. The final connections are VAE, Clip Vision, output, and Start Image. First, drag out the VAE socket and load the WAN VAE FP8 version. Next, drag out the Clip Vision socket and select Clip Vision Encode node. Drag out the Clip Vision socket and select the model. Finally, we load the image node. It's not safe to connect the image directly. Different sizes and resolutions could cause errors. To prevent this, we'll add a resize image node to force the correct resolution. With upscaling, this ensures HD or 4K output while keeping a 16:9 ratio. The target resolution is 1024 by 576. For resizing, we'll use Lanczos interpolation and set the method to fill or crop. This ensures the image is adjusted to match our resolution while staying divisible by 2. Now, we connect the image socket to the WAN image to video processing node. Next, let's enter the prompt, girl wears sunglasses and smile. Now we add the load clip node. Select T5XL U1 FP8 scaled and set the type to WAN. Then, we add the VE decode node and the VHS combine node. Since one generates videos at 16 FPS, we'll adjust that accordingly. I prefer MP4 format, so we'll select H264 MP4. CRF, or constant rate factor, controls compression. Lower values give higher quality and larger file sizes. Higher values, like 30 CRF, compress more but lower the quality. For high resolution and a high data rate, we'll set CRF to 10. Now, let's generate the video by pressing Q. This is the quality of the Q4 GGUF model. If possible, try using Q6, as it gives me the best quality and runs without crashing on an 8GB VRAM GPU. Now, let's compare the quality of Q6, Q2, and Q4. In this tutorial, I'm using Q4 because some GPUs may run out of memory with Q6. So, the best option for most users is Q4. Q2, on the other hand, degrades quality too much for my preference.